Greetings, welcome back to video lecture series on computer architecture. My name is Dr. Prashant Bachanna. In this video, we shall be learning the micro operations, that is in the second module of the computer architecture. Micro operations are the operations which are performed on registers. So in the micro operations, we'll be learning the different types of micro operations available. That is register transfer micro operation, arithmetic micro operations, logical micro operations, and shift micro operations. So we'll see all these micro operations one by one. So what is micro operation? A micro operation is an elementary operation performed with the data stored in the register. So whenever CPU execute any processor, it executes the operations with the help of the registers. So the operations which are performed on the registers are called as the micro operations. So here we have these types of micro operations, that is register, arithmetic, logic, and shift. So in the register micro operations, already we have seen in the previous video, that is the different types of register micro operations available, that is transfer with condition and without a condition. So in the register transfer micro operation, the contents of the registers cannot be altered when the transfer of data from the source is destination is done. So we have seen all these register transfer operations in the previous video lecture. So in this video, we will see the arithmetic micro operations. So at the name itself, it is indicating in the arithmetic micro operations, it is going to perform the operations like addition, subtraction, multiplication, division, increment operation, decrement, and the other arithmetic operations. So this shows one example of the arithmetic operations. The instruction written is R2 plus R3. And so this instruction will execute, will add the content of the register R2 and R3. Let us say the R2 and R3 is having some 4-bit of some data, and R3 is having some data. So this instruction adds the content of R2 and R3, and the result will be stored in the R1. So in the same way, we can write the operations like this. That is R2 plus R3, like 1 into R2 minus R3. This is an example of subtraction. So there are different types of arithmetic micro operations which will perform. So with the help of these notations, we will be writing the instructions. So this table shows some of the arithmetic micro operations performed. As an example, R1 plus R2. So this arrow shows the content is stored in R3. So this adds the content of R1 and R2. The result will be stored. Then the next instruction is R1 minus R2. The result will be stored in R3. That is the content of R1 minus the content of R2 is subtracted from this value, and the result is stored in R3. Then if you want the complement, so this R2 bar, if you write R2 bar, it indicates if you want to complement a number, then this instruction is used, operation is used. Then if you want to choose complement, then we have to take the complement R2 bar, then we have to add the 1. So this is called as the choose complement of the number, which is to negate a number, because the values or the data stored in the computer will be in the form of zeros and ones. So to negate a number, we have to perform this complement, and we have to add 1. Then the number is converted into the positive number to the negative number. Then we can perform the subtraction operation, that is R1 plus R2 bar plus 1. So this shows, so this instruction can in generally be written as R1 minus R2. But we cannot write directly R2 because all the values in the computer will be in the form of zeros and ones. So first the number will be converted into the negative number by taking a complement and by adding 1. That is what is by doing a choose complement of a number is converted into a negative number. Then the next micro operation available is R1 plus 1. So this is to increment the register by 1, and R1 minus 1 to decrement the to decrement the number by 1. So that is an increment and decrement operation. So these are some of the operations like addition, subtraction, increment, decrement are some of the arithmetic micro operations available. So once we see these arithmetic micro operations, we'll see the circuits which are used to perform all this. So we have seen the different types of arithmetic micro operations. Now we'll see which kind of circuits are used to build these micro operations. So binary adder is a circuit which is it is used to implement adder operation with the help of the register. Then the digital circuit, the addition can be done in like 2 bits and 3 bits. So with the help of a full adder. So here the full adder consists of the inputs A, B, and C. So with the help of a full adder, we'll be building some of the binary adders. So here we're taking an example of 4-bit binary adder. So the 4-bit binary adder adds 2 4-bit numbers, and it will also generate the carry also. So this is constructed by with the help of a 4 full adders here, as you can see. And A, B are the input, and C naught is the initial carry. Then this is S naught is the sum generated from the first adder, and C1 is the carry generated from the first adder. Then the carry is given as an input to the second full adder, and so on like this. The carry is forwarded here, and we get the final carry and the 4 bits of the this thing. So let us say if we take these two numbers as an example. So if we add it, so we'll get the outputs like this. So this 4-bit binary adder is used to add two 4-bit numbers. So like this, to perform different types of micro operations, we use different types of the hardware circuits. So there's one more circuit which can be like this is an example of 4-bit adder subtractor. So this circuit will do both the operations of adder and subtractor. So from the previous 4-bit adder, so you can see there's an extra XOR gate available, XOR gate connected to the each full adder, and that carry will be the same carry is forwarded. So this circuit performs both the adder and subtraction operations by taking the choose complement of a number. So the choose complement of a number is done with the help of an XOR gate. The same thing is mentioned here. Then the next circuit available is the 4-bit binary incrementer. So if you want to increment a number by 1, so then this is implemented by using 4 full adders here. So this is the first full adder, second full adder. So each time here also the carry is forwarded, and X and Y are the 2 inputs, and each time so it will use sum and carry, and then the same carry is forwarded into all the 4 full adders. So this circuit performs the binary incrementer. Each time the number is incremented by 1. Then we'll see the arithmetic circuit now. So the arithmetic, so all this, so we can build a common circuit which can perform all the arithmetic operations by using a single composite arithmetic. So instead of designing the individual adder and subtraction, so we can design a common arithmetic circuit which can perform all the arithmetic operations. So this can be done with the help of four full adders and 4 multiplexers. So with the help of this, we can build a common arithmetic circuit as shown in this figure. So this figure shows the 4-bit arithmetic circuit, so which is constructed with the help of 4 multiplexers here. That is 4:1 multiplexers. So what is multiplexer? 4:1 multiplexer. It is having 4 inputs and 1 output. So each time 1 input is selected. Then these 4 multiplexers are connected to 4 full adders here. So as we have seen, 4 full adders, and each full adder is having the inputs A, B, C and sum and the carry. So this all the things are connected here, and it is done with the help of it. So the initial carry in is given, and with the help of 2 select lines here, that is S0 and S1. So the truth table will be like this: 00011011. So each time one of the multiplexer will be selected, one input will be selected, and each time simultaneously one multiplexer and one full adder is selected. So this 4-bit arithmetic circuit is used to perform the arithmetic operations. So once we done with the so we have seen the different types of arithmetical operations performed and the circuits which perform the arithmetic operations. So now we'll see the logical micro operation. So in the logical micro operations, we are going to perform the operations like AND, OR, NAND. All these operations are performed. So let us take an example here. So here P within condition R1, R1. The content of this is given. That is the OR operation is performed here. So let us say R1 is having a value 1011 and R2 is having 0. So if you write if P equal to 1, so if P equal to 1, the OR operation is performed. So OR operation is basically an addition operation. So like this, the different types of logical operations are performed. So the logical micro operation performed are AND operation. So we know the truth table and the symbol for the AND gate. Then similarly OR gate which performs addition, and it performs usually the multiplication. Then inverter, buffer, the symbol for buffer. Then the NAND gate, the truth table for the NAND gate. Then NOR, XOR, and XNOR. So these are logical operations, micro operations performed on the register with the help of the registers here. So here you use the symbols, common symbols. So for OR operation, we can use this V symbol, and for the AND operation, this symbol is used here. Then for the complement, so like this, the instructions will be written here to perform the different types of logical micro operations. So if you use this plus symbol, it will perform the OR operation. So by using the different operations symbols, these logical operations are performed. So this table shows the list of micro operations which are performed. So to clear the register, we will write 0 arrow towards F. So this will perform the clear operation. And to perform AND, so to perform the AND logical micro operation, so this symbol is used. So if I write A and B, it will do the AND operation between the data stored in A and B. So similarly, we use the transfer operations to transfer the content from any register to the other register. So we use this transfer operations here. Then similarly, to perform the OR operation, we can use the plus symbol, or we can use A and A or B. So to perform XOR operation, this symbol is used. XOR operations. For NOR operation, this symbol is used. XOR, to perform XOR. So this shows, let us say, like to set all the bits to 0 to make, let us say in a register we are having there's a register of 4-bit. So if you want to make all the bits as 1, so we use this symbol here. So the table shows the different micro operations like AND, OR, NOR, XOR, NAND. So for NAND operation, this symbol is used. To complement the number, this symbol is. So with the help of these notations, the logical operations are performed inside the computer architecture. So how to implement these hardware implementation of these logical micro operations? So in order to perform these logical micro operations, we have to design some hardware implementation. So this figure shows so this circuit hardware will perform the operations like AND, OR, NOT, and XOR. So which is constructed by using a 4:1 multiplexer, which will have 4 inputs and 1 output, and the truth table is given here. So for each select lines for S0 and S1, for each time for this 0, 1, 2, 3, if S0 and S1 is 1, if S0 and S1 both are 0, 0, then this circuit will perform the add operation. Then if the select lines, if the select lines are 0 1, then this circuit will perform the OR operation. Then if the inputs are 1 0, that is 2, the XOR operation is performed, and if both inputs are 1, that is these two select lines, it will perform the complement operation. So this diagram shows, so with the help of a select lines, here select lines, the multiplexer is used to perform the 4 operations like addition, subtraction, like AND, OR, XOR, and the complement. So AND operation is performed. So when S0 and S0, when S1, S0 and S1 are 0 0, so then the circuit will select the AND circuit, and the addition of AND operation is, AND logical micro operation is performed. If S1 S0 are 0 1, that is 1, then OR operation is performed. If it is 1 0, then XOR operation is performed, and if it is 1 1, then the complement operation is performed. So once we learn these logical micro operations, now we'll see the applications where we use these logical micro operations. Now once we see the logical micro operations, we'll see like what are the applications of these logical micro operations. So logical micro operations can be used to manipulate any individual bits or a portion of a word in a register. So all of us know the CPU or the processor executes all the operations with the help of the registers only. So the values present in the registers can be individual. Let us say like this is the R1 register, which is having some data. So if you want to alter or manipulate the individual bits, so that can be done with the help of these logical micro operations. And for the same, the hardware circuits are built. So let us say, considering data in the register A, like we are seeing here, if you want to alter the bits, let us say to select an individual selective set. So we will write like this: A plus B. So this will perform the AND operation. Then to perform the complement, we'll do this. Then to select the clear bits, we'll write like this. So to mask the bits, we'll write to clear. So this instruction is used to insert a particular bit or into the register value. So we can this micro operation instruction is written, and to compare we use XOR operation. So these are some of the applications of logical micro operations which can be used. So in the today's video lecture, we have seen arithmetical and logical micro operations. In the next video, we'll be learning the other micro operations like shift operations and all. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.